Our unknown can be found in both sides of this given equation. It's represented by the variable x. But it is also noted that the variable or the unknown is found as part of a grouping symbol. Hence, we are going to manipulate first our coefficients outside the grouping symbol using the distributive property to come up with an equation where we usually do all the necessary steps in solving for the value of the unknown. Let me copy the equation here. So you have 2 times the first grouping symbol, x, or group rather, x minus 2 is equal to 3 times x plus 3. So before we could solve for the value of x, or this is actually the first step, we are going to distribute that here and here by multiplication. So 2 times x is 2x minus 2 times 2, we have 4. Next, on the other side, we are going to do the same step. So 3 times x is 3x. 3 times 3, we have here a result of 9. Now from here, we can apply properties of equality by deciding which side should contain the unknown. And let's have it on the left hand side. In short, we are going to remove this minus 4 by adding 4 here. So that 4 minus 4, that's 0, leaving 2x. We are going to pick this side for terms or with coefficients of the unknown. Next, do the same thing on the other side to retain equality. Hence, we have here 2x is equal to 3x. 9 plus 4 is 13. Next is to remove this 3x here because the right hand side should only contain constants. We're going to subtract here 3x and do the same thing on the other side as well. So we have 2 minus 3, we have negative 1 or simply negative x. The other side, this is again 0. What we have here is positive 13. But this is not yet the final result for the unknown. Since we would like x, not negative x, we will divide this by negative 1. So that would become 1x or simply x. And doing the same thing on the other side as well. Or multiply both sides by a negative 1. Either way, the result for our unknown is equal to negative 13. Of course, if you don't like negatives, from here, you can apply the symmetric property, interchanging both sides of the equation without necessarily changing the values or the coefficients of both sides. But with this, we will have this as our result. Don't worry if it's negative, we can always check this and verify whether that is correct or not. It's important to also to record that when we are going to use this checking, we are going to go back to what was the original given equation, not the second version nor the third version. We are going to use the original equation so that we would know if this is something or as a result from an error on the process. Because even if this will satisfy the third version or the second version, we are not yet sure because there might be some errors moving from the original to the second and to the third. So we're going to use the original equation and we are going to substitute the value of the unknown being equal to negative 13. So by substitution, we have this 2 times negative 13 minus 2. The other side will have 3 times negative 13 plus 3. We are checking, so we are going to place here question mark, and our goal is that for both sides of the equation to have the same value. So by PEMDAS, you will have here 2 times, that's negative 15. You need to review as well your operations on integers. The other side, still question mark, you have 3 times negative 13 plus 3 is negative 10. And the final step, 2 times negative 15 is negative 30. The other side is also 3 times negative 10, which is negative 30. Seeing that both sides of the equation will have the same result, the checking is already done, this is already a verification that the value of the unknown solved earlier being negative 13 is the correct value of the unknown for this given equation. Join us to the next adventure involving the unknown.